Today we're going to continue with our identities, and chapter 5.6 is our last identities that we are going to talk about, and they are called half-angle identities. Half-angle identities are exactly what they sound like. They're half of an angle. They are derived actually from the double angle. These are your identities that you actually will not have to memorize. I will give them to you on your exam. There are 3 of them, just like before. So cosine of, let's call that, instead of O, cosine of A divided by 2 is equal to plus or minus the radical of 1 plus the cosine of A all over 2. So if you're thinking about this, this angle inside will always be larger than this angle. So if I said your A value was 45, right? Half of 45 would be right there, right? 22.5. If this was 60, then this value would be 30. Our next half-angle identity that we need to know about is the half-angle identity for sine. And again, it's a plus or minus 1 minus the cosine of A all over 2. Again, we got to figure out the plus or minus. That will be dependent on where the A over 2 is. What quadrant is it in? Now, tangent actually is a little bit different. Tangent actually has 3 different ways that we can write them. Now, the first way can be seen by taking the sine and dividing it by the cosine. 1 minus the cosine of A all over 1 plus the cosine of A. Now, for this identity, for this half-angle identity, we do have to figure out should the value be positive or negative. For the other 2, we actually don't need to do that. So sine of A over 1 plus the cosine of A. This is also a little bit better because you notice that there is no radical. And we can actually flip our fraction. So I can multiply by reciprocal potentially. And if I have the cosine on the top, it's actually going to be 1 minus cosine of A all over the sine of A. Now, where is this derived? So let's derive the first 2. All right. So derive half angle. All right. So I'm going to walk back through one of our double angles. So one of the double angles that we talked about was the cosine of 2A. And there's 3 different ways we could write it. Well, one of the ways is like this. Let me change that to an A. So the double angle of cosine is equal to 1 minus 2 sine squared A. So basically what I'm going to do is I'm going to get rid of everything but the sine and the A. So I got to get rid of the 1, I got rid of the negative 2. Let's get rid of the squared. So I'm going to move the 1 over to the other side. So negative 1 plus cosine of 2A is equal to negative 2 sine squared of A. Divide by negative 2. Divide by negative 2. So I'm going to keep it as a fraction and move the negative to the numerator. All right, and start to notice that 1 minus cosine 2 of A, I'm going to take the square root. And when I take the square root, I got to put a plus or minus in front of it. Now, how this is also different is notice that you have an A here, and notice you have a 2A here, right? So we could also say it like that. So what's half of A? A over 2, right? And then you'll just have the cosine of A. So again, this value will always be larger than this value. So just another way to write that. So notice that now I have my sign. So let's also do the other cosine. So cosine of 2a is equal to 2 cosine squared minus 1. So we'll add 1 to both sides. And I'm going to divide by 2. And I got to get rid of that radical. Bam. Get rid of the radical, put a plus or minus in front of it. Okay? So our tangent is going to work exactly the same way. So we're not going to derive that right now. We might do that a little later. So let's get into our examples. All right, so I'll show you a few examples. So here it is. Our first type of example will look like this. Find the exact values. So here's our first one. Cosine of 15 degrees. Well, the cosine of 15 degrees is not an actual value that we know off the unit circle, right? So what we want to do is we know that 15 degrees is equal to the a over 2. So if I multiply both sides by 2, I know my a is equal to 30. So I get my 30 degrees. So I'm going to say now 15 degrees is in the first quadrant. So I know I'm going to be dealing with a positive radical. And I'm going to say 1 plus the cosine of 30 degrees all over 2. So again, I don't really need the positive. I'm going to go ahead and replace the cosine of 30 degrees with the fraction root 3 over 2. Okay, and make sure that your radical does include the denominator, right? So all of it's going to be included. Make it be a common denominator. So 2 plus 2 root 3 over 2, and then all of that's divided by 2. Right? The 2's basically move into the denominator. So it's actually going to be over 4. And at this point, I'm going to separate the radical sign. And what I'll be left with is 2 plus the square root of 3 all over 2. So we could check this if we had a calculator. You could easily plug in 15 degrees and get an answer. You can plug this guy in and get an answer. So let's try another one. Let's try tangent. So tangent of 22.5 degrees. That is definitely a number I don't know. So again, I know that 22.5 degrees is equal to a over 2. So if I multiply both sides by 2, I am going to get my a value as 45. Now, remember I said that there are 3 different ways that I can solve for the tangent of 22.5. I can either know that it's positive and then use 1 minus the cosine divided by 1 plus the cosine and then take the square root, or what I can do is not worry about the square root and work with these numbers. So that's exactly what I'm going to do. Let's work with the top one. So I'm going to work with sine A all over 1 plus cosine of A. So this will be 1, oops. It'll be sine of 45 degrees all over 1 plus the cosine of 45 degrees. We already know what the sine of 45 degrees is. And I know what the cosine of 45 degrees is. And so what this is going to equal, radical 2 divided by, and this will be 2 plus root 2 all over 2. Division is the same as multiplying by the reciprocal. And we're going to notice that, boom, those 2's cancel out. And we're left with our answer. Let's go ahead and rationalize our denominator. This is not too bad of a denominator to rationalize. So this will give you 2 root 2. Root 2 is minus, oops, not 4. Radical of 4, but taking away the radical, making it become a square root. Conjugates, 2 times 2 is 4, minus 2. 2 root 2 minus 2, all over 2. And a lot of things are going to cancel out. And I'm running out of room, so I'm going to write my answer. Follow the line. As this. Root 2 minus 1. So there is our finding exact values.